Say, huh? That looks better with the words, right?
Yeah. I'm sorry.
See how close I can get in, see if I could,
Sorry.
no, you're good, you're good. See if I can get it too tight.
Push it down a tiny bit.
Mm-hmm.
That's perfect.
Mm-hmm.
For the most part. Yeah. Or go stand over there and we'll say.
Can you see me if I do? Learn how to do crafts today. Can you see that?
Yeah.
Sorry, using the black.
But if he's standing, because he's
Oh, he's left-handed.
He's a lefty, so he's over
Oh, so
here.
now we gotta move it again.
Right?
Yep. Yep. Good job, Christina.
Yeah. Like,
Thank
he
you.
does that a lot. He tends to face.
Mm-hmm.
So if he is a lefty,
Sorry, Gordana, we're gonna have to move
I'm so
that.
sorry.
right? You would go like this. Right? And then you would do.
Yeah. That's perfect. I kind of like seeing the door because it's like, who's gonna come in? But yeah, do you know how to zoom on in this thing or no? Not really. Here, I'll let you play with it. All right. You're really good with your left hand.
I know, it's crashing my laptop.
Yeah, I don't understand that. That's my favorite.
We should do that. We should actually do that.
Are
Are you on a map? Are you on a map? Five to 2/3 power?
Well, we're doing it from your left hand.
Yeah, because if the camera were here, you're a lefty, so you would be facing that way. So that way, this camera is here, so now you can write.
Text the office. I was gonna say, Ryan missed a shot, we gift him the video. We did turn the air down, by the way, so you get a chance. It's just with a lot of people in this room, that's what did it. Because it was running at 75,
Whoa.
but it touched it down to 72. That's the effect of that body, you can do that. Oh, you go ahead, Denise.
I just need to go steal a chair.
Makes you want to teach, huh, Christine?
No. To you,
No,
Professor.
no, that's why I'm going to take it when I was with the table.
Okay.
Okay, what do you want to do with that?
I'm going to give him a replace.
Replace it?
Does it bother you that we're missing a desk?
Well, no, I don't know how many students.
Go for it.
He has any.
No, he's not gonna fill them all.
Oh, okay.
Go ahead, though. I want to be symmetrical.
It's mirrored. That's not like, wait, why is this like that?
I can check it out on YouTube.
Well, have fun.
Thank you. Would you? I think I'm just gonna sit here, so I'll block you.
Okay, put it up, let's go.
So it's going to be recorded?
Yes. We're gonna make this our first recording. We'll get to Mariah. She probably thinks she's not gonna get the class. You gonna sit back there? All right.
Yes.
Okay, start now. You know, I said it right. Okay, let's start with our class today. I think I wanna review all the different, first of all, let's make a distinction between the rules of taking derivatives, right? Like product rule, power rule, chain rule. These are rules. And you guys are probably about quotient rule, but I won't tell you. Let's distinguish between those. And then the other stuff you want to see is the different derivatives you need to know to do those. I'll show you what I mean. Okay? All right. Let's see, you guys ready? Before I do that, would you like to see any of the problems?
Homework?
Yeah.
I thought we were doing.
or because you'd like to have me do a problem that's on that page that I didn't do already.
We didn't work,
Or maybe I should do some more.
we didn't work on them.
All right, okay. All right, let me go ahead and review the rules then, okay? So here are the rules I'm gonna review. First, we gave you the power rule. By the way, I should probably label these rules for derivatives. Rules for derivatives, the power rule is the first one I gave you, okay? I could probably give you a more of an extended understanding than I did the very first day, right? Because you figured it out, some things on your own. So if, it's gonna be the format, if there is, if f of x equals k x to the nth power, where k is a constant number, of some constant real number. It can be a fraction, it can be a whole number, it can be a square root, it can be, also it's a real number, right? That's the only requirement, that it's a real number, all right? If it's a real number, then f prime of x is equal to n k x to the n minus 1 power. I'll do examples over here for each one, right? The examples will be over here. So a good example of that would be, let's say f of x is 1/3 x to the 6th power. How about that? 1/3 x to the 6th power. Then f prime of x, according to this, is you put, say 6, you'll say 6 times 1/3 x to the 6 minus 1, right? Which then equals 2x to the 5th. Okay? 2x to the 5th. All right? Any questions on that? That's pretty straightforward. We hit that pretty hard for about 3 days. We said that there's like, so that even comes down to if you have like f of x is some g of x plus h of x, and each one of them is an exponent, a power, you could do it on each one separately, right? That's pretty obvious. So that was the power rule. It's got an example there too. This is the page in the, when you start your calculus class. I don't have that tucked away in your bag. Flop that open while your teacher's teaching. The teacher may just prove this rule for the first half hour, you just yawning through it because you already know what it's doing. We did cover the definition of a derivative. We did do that. All right, let's take a look at the second thing I covered was my own little thing, which is what if we have an exponential function? An exponential function. And what that means is what does an exponential function mean? You kind of need an exponential function. Again, you won't find this separated out in books. They just sort of start doing it. And I don't think that's confusing, so I'm going to cover it. So if f of x equals some constant k, right? Some constant k to a power of r of x. Okay? Okay. Some function of r of x. Then f prime of x, this is one condition I need to cover separately. F prime of x is always going to be k to the r of x power times r prime of x, which is foreshadowing the chain rule. It's foreshadowing the chain rule. I'll do two examples of this one. The only requirement is that k is a real number, constant. It's a constant. Okay? If it's a function, then that gets us into the chain rule. which we'll cover next. So here's some examples. I'll do a very basic example first. Let's say f of x is equal to 10 to the x power. And you want to find the derivative of that. And you just copy down the function again. F prime of x is 10 to the x. You can say times 1, right? Because the derivative of x is just 1, isn't it? But this is the same number. So look, the derivative is the same thing as the function. It's the same thing. For that matter, because I don't know how much they covered it, so I'm going to keep reminding you of it. It should have been covered in pre-calc, but it may not have been. If y is equal to e to the x, where e is 2.7183, something. You might wonder, why is that so important? Because a lot of things in nature decay with that as the base. It's just amazing. It's one of those amazing things in life that many things decay with this as the base. So that's why E is so important to calculus. That's the solution to a lot of calculus problems, the E function, which is amazing. F prime of x is just e to the x. So no problem when it's just something simple like that, because what's the derivative of x? 1, right? I should have put times 1. I think Bailey was saying I should put the times 1 there, right?
No.
But you see it's just going to be times 1, right? Let's do somewhere it's not just 1, though. That's what gets me more fun, doesn't it? Good questions on this? Because I'm reviewing all this. I'll do a lot of action the last day or two. Let's take some more examples. Let's just say if f of x is equal to e to the 3x. Okay. Then f prime of x is equal to the same thing as before, but this time the derivative of 3x has to be considered, doesn't it? And that derivative is just the number 3, which makes this 3e to the 3x. You do enough and you should know right away, when you have e to the kx, it's just going to be ke to the kx. You'll start learning that. How about one more example with a little more complex? Get any questions, just interrupt me, right? Okay, what about if f of x equals e to the 3x squared plus 2x? So that's the exponent, 3x squared plus 2x, everybody, right? I could put a parenthesis on it, it doesn't matter. Then f prime of x is equal to the same thing. It's the same thing as it was before. E to the 3x squared plus, just make sure you don't have a copy error, right? You could copy it down wrong. Teacher will mark you wrong all of a sudden. Times, I put this in parentheses, 6x plus 2. How did I get that? Using the power rule, right? The derivative of 3x squared is going to be 6x. 6x plus 2 is the derivative of 2x, 2. So this would be the answer. And what a lot of books do is they seem to always put that first, right? You'll see this answer in the back of a lot of books. Because all calculus books have their answers in it. They'll switch and put the 6x plus 2 first. But it doesn't matter. I'd probably mark you right. No, probably I would. So you're telling me you understand, right? Picky teachers might want it first to be a coefficient of the E. Because I guess I won't deal with that. It's okay with me being at the end. Let's just leave it at that. Did you ever take calculus? You're like glad right about now, right? Yes, okay, great. Okay, any questions? Mariah? Jordana, you with me?
Yeah. You never really need to distribute the final answer
No.
out, right?
Nobody ever does that.
Okay.
Because then you get people like me say, well, you need to factor. Right? So no, I don't think you need to do that. I would argue that's simple. It seems like two terms, right? Determine the parenthesis and the E function. That's a good question. All right, let's move along. Let's look at the chain rule. I think I just told you what it was before. I don't feel in a mood to prove it today. Friday's a good day for proofs, don't you think? So yes. Yes.
So you have the power rule, the chain rule, and then there's a product rule, right?
I'm going to cover product.
Is the exponential functions, is that something different, or is that included in the power rule?
Only smart people ask that, so congratulations. How do I explain it to you? It's a Wilson creation. I feel it's a combination. It's, how do you say this? Separated at birth, power rule and chain rule. It's like I've married them together. This is the baby that was created, this exponential rule. Right? And the way I figured it out was students were struggling with it. And I realized I never explained to them you have to take the derivative of the two. And I would say, well, the chain rule says, and they'd say, well, that's not really f of g of x. And I said, well, yes, it is. The e is the f. And they go, the e is the f, we would tell them. So that's why I stopped doing that. I just said, let's just teach it separately. And this actually can be proven, so I feel good about it. And you don't prove it using the chain rule. Isn't that interesting? You use the definition of a derivative to prove it, and as you can see, it's going to be pretty long proof. All right? I feel like I didn't answer you, but in my not answering, I did answer. Right? Yeah. I just told you why I didn't, I guess. All right. Let's in fact go to table first. Now we'll do the Aretha Franklin song thing. You guys will, chain of rules. It doesn't help you to learn it, it's just fun. But sometimes you sing a song that helps with certain things, right? It doesn't help, just lights the calculus class up. All right, so what it says is, if f of x, I gotta change letters now, sorry about this, is written as r of s of x, right? That's really what we're talking about here. Then f prime of x, this is the whole point, is r prime of s of x times s prime of x. And I put the parentheses in on purpose. So you got to take the derivative of the inside function. That's the way you remember it. This is why I don't like to apply. I'm going back to Mariah's question. This is why I don't like to apply it to the exponential, because how do you say it's inside? It wasn't really inside, it was power, right? This is primarily when they're inside, and I'll show you what I mean in a moment. My examples will tell you everything. And you want to use these examples when I give tests and quizzes, because that's how you learn them. A good teacher will let you use the notes, because they realize that that's part of the class. You learn to use it. You're going to do it in your homework anyway, right?
Using notes when what?
On my quizzes, I'll let you use them. Open note quizzes. You get the quiz on Friday on the power rule.
My professor didn't let me use notes.
Your professor, as I said before, this is on tape, so I'm not going to say it. I'll answer you after the class. And I won't be profane, promise.
I know.
The good calculus teachers don't care. They want to see if you know how to use the rules. And guess what? I've used them and taught them so much, I don't have to. I know them now. That shows how you're going to learn, right? Some things you don't memorize, just use them so much you can do it. I think a lot of learning is like swimming. You know how to swim? Too many water, you can do it. Have you had a class lately?
No.
But you can still swim, notice. Don't ask me that, though. All right, okay. Let's look at these examples. I'll put the examples here, okay? So here's just some examples. Again, the most basic example that I like the most, and I love explaining, is when f of x is equal to, say, x squared plus 5 to the 60th power. I mean, I could wait for you to multiply that out when you use the power rule, right? But this is going to take at least 2 hours to do. This is where you need the chain rule. There's just no way that that's going to happen, right? Go ahead.
I guess it's more so a rhetorical question, but it's like a confirmation question. You'll be able to tell based on the problems which rule you should use.
Yes.
It'll be easy to tell.
Comes from practice. It's really all about practice.
Because I know, like on the examples you gave us, you told us which ones to use, but I'm just saying.
Exactly.
Problems.
Exactly. So that's why at the end of the class, I mentioned, I think I mentioned it, I implied it other than all of you were here, but I said it to you, Bailey, that I love the worksheet I gave you the last day of class. I'm gonna give out like Thursday or Friday, a worksheet of all of them combined. That like mix up the problems, so you have to think about which one to use. This is where you're gonna get in the summer, you're gonna use your notes. You'll get good at it. What I'll do in August, right before you take your calculus class, you guys know you get a semester of free tutoring with calculus. You should probably go to your own engineering school to get it. You'll just forget about me. Certainly feel free to do that, but I think you'll find that you want to keep those notes because they're going to be helpful. The big arc of the first semester is derivatives. That's going to be the huge thing that's going on. The answer to every question is going to be take the derivative. You had a question. You were thinking though, weren't you? Yeah, I can tell. I can tell. I see the smoke coming off your brain there. All right, so this one right here, then, I like seeing then f prime of x is equal to, I'll move out of the way in a minute, is 60 times something to the 59th power, yes? The something is this in here, isn't it? Because that's the power rule. This is the way of me reminding myself that I have a power rule as the outside function. The power rule says what it said. You put the 60 in front, you take away 1. So I'll just recopy this now. But out here, I have to take the derivative of the inside. And the derivative of the inside is 2x. Now, as I said before, a lot of teachers will let you leave it like that. I would let you leave it like that. I would, because usually you got to plug in a number anyway, right? So I would let you do that. But really, you should put the 2x in front, which forces 120x. This is what it would be. If you look at the back of the book to see if you got it right.
So usually you have to plug in a number?
Let me explain. So I'll use, and my problems a lot, I'll say, what's the derivative at x equal 3? You're gonna have to put an x equal 3 here. Here it doesn't matter, right? This is the way it would look in the back of the book if you look at the answers in the back. This is probably what will be there. You'll see that in the chain rule assignment I gave you. They gave solutions in the back. They're always a little different.
Oh, you did 2x.
So one fun thing in calculus, when you get the answer, you have to match it up with the answer key. And those are fun because you get to see that expressions are equivalent to each other, right? This is one of those cases. Like these two are equivalent expressions, aren't they?
You did the 2x times 60?
Yeah. See, these two are equivalent expressions, aren't they? This expression here is the same as this here. They're equivalent. Okay, so this is an example of the chain rule, but I'm gonna do some more examples.
Can I ask another question?
Yes. Yes.
Like, I know we did it before, so I should have asked why.
No, that's why we're reviewing. It's called
Why
review.
were you able to do 2 times 60 when it's 2x and not 60x? Or like, I don't know.
Okay, so the real reason I'm supposed to tell you is A, B, C, A times B times C is equal to C times B times A, isn't it? Because multiplication is commutative. It doesn't matter the order you do it in. You can put it could have been 20 in the x on the end, right? because the order you do things doesn't matter. So I'm just saying one way they do it in the teachers is they take the whole expression and put it against this. You'll see that a lot. But me, if you do this for me on a quiz, I would accept it. I'm just warning you that when you look in the back of the book, you think, I got it wrong, man. No, you didn't. It's another way of expressing it. You'll see that with a lot of the power rule problems I give you.
Yeah, with the homework you gave, that was
Right.
the part that was kind of.
Right, sure.
It makes sense.
Okay, and we'll look at some of those in a minute, right? All right, let's look at another example of the chain rule. How's that? Let's say f of x is equal to, here's one of my all-time favorites, if I can remember how to do it, okay? Oh, yes. E to the 2x minus e to the 3x, all raised to the 12th power. Now, there is no way you can do this without chain rule, right? There's just no way you can be able to do this. Understood? I mean, how do you multiply that out to the power of 12? I'm not sure I know how to do that, actually. Actually, I do, but it's not important. It takes forever. F prime of x, by the chain rule, says, okay, fine. 12 to the 11th power. And then then you write this down, right? E to the 2x minus e to the 3x. And watch this. The derivative of the inside. Anybody want to? Oh, I want somebody to tell me. What's the derivative of the inside? Jordan?
I can't remember what the rule we said.
Look it up. Look it up. Look it up. Look it up.
Okay.
Look it up. Look it up. Sorry. Look it up.
Oh, it's 2e to the 2x
Minus.
minus 3e to the x.
That's it. Capiche? Nothing to bring in front. Now, here's a case where you just don't have anything to bring in front, do you? It's just e functions and stuff. I wouldn't bring it in front now. No benefit, is there? There's nothing to combine, right? This is a really good problem for a test. Because it makes you use other rules, doesn't it? That's the thing about the chain rule. It makes you use other derivative rules, doesn't it? This is the derivative of the inside, yes. Okay. I can't wait to what I'm going to show you after this. I get to the new derivative stuff. This just provokes a lot of interesting questions about the derivative of sine and cosine. Need another example of chain rule, or maybe I'll just do one of the chain rule problems from the homework and then continue with the rules for sine and cosine. Yes?
Yes, but you also said you was gonna cover it regardless,
Yeah.
the whole thing.
Well, yeah, I am, but I thought maybe sticking one in here when I got to this would be nice. Let's do one, and then I'm still going to continue. I want to do sine and cosine. I want to do product rule. Excuse me.
Yes, I'm here.
Yeah.
10 sine, cosine.
Yeah, I know they're on there. All right, so let's do one example. Let's not do those sine and cosine rules yet. Give me just a chain rule without it first.
Yeah.
Would you like to give me the honors? Yeah. I don't have it in front of me, so guess what you get to tell me.
Okay, I want to do one of the ones that have a fraction.
Let's go.
Okay, so y equals the square root of x squared minus 7x.
Like this, x squared minus what? Like that?
Yeah, minus 7x.
7x? Then what?
That's it.
Oh, good.
I'm just saying,
This
the answer sheet has.
is a very good problem for chain rule. It's excellent. Because the first thing you have to do is rewrite it. Right? You have to rewrite it. You have no choice, right? So I'm going to rewrite this. By the way, I'm going to make an f of x to be consistent. Is that right? F of x is equal to x squared minus 7x to the 1/2 power. That's the way I see that. So I went from here to saying 1/2 power. I just rewrote it. So now I can use the power rule, chain rule, whatever I want to use. Questions on that? Okay. So f prime of x is equal to 1/2 to the minus 1/2. Because 1/2 minus 2/2, which is 1, is minus 1/2. So we have minus 1/2. Of course, in here is x squared minus 7x. But this is all times the derivative of that. What would that derivative be? I think it's the rise to the term. What would the derivative of this be? To what? 2 in front.
2x.
2x what?
Minus 7x.
Minus 7. That's it. Lose dx.
Oh, yeah, you're right.
Right? I thought of you when I saw this because the other day, the same problem came up. So when you have the derivative of a linear function like that, it's just coefficient. So this is the derivative. Some books might move it in front, right? But there's no benefit of that. Don't get hung up on that stuff, okay? Just make sure that you know how to evaluate your answer and see that it looks like what the answer, that the answer key and you were right. If you come up with this, this is the answer key right here in the blue, conclude that you're right, not that you're wrong. Don't get hung up on that. Teachers get upset when they, not me, but teachers get upset when students don't see this.
Would you prefer it written that way? Or
I don't care. I would accept this
do
way.
you
Me.
think professors will want,
All in the ball yard.
well, no, there's one written down, another way written down on the homework that's not written down.
Okay, I'm gonna show you. Here's another way. You see this minus 1/2? A lot of people don't like negative exponents, so they put this expression right here below. Let me show you. It would be 2x minus 7 over, that's times 1. 2 is on the bottom, x squared minus 7x to the 1/2 power. They would write it like that. This is also correct. All three of those are correct. All three are correct. I believe on an exam, a professor would be hard pressed to mark you wrong. They might prefer to see the book, the back of the book. The reason I'm bringing this up for you is because when you're doing your homework for the professor, you look in the back of the book and swear you're getting them all wrong. But you're not. You're not really getting them all wrong. You just have to know these are all equivalent. Here's a little thing about calculus teachers in the real world. If in class you ask about this and you don't see this, please don't be offended if they say, see me during office hours. Because they don't want to do algebra 2 or pre-calc during calculus class. But I will because it's summer. That's what the summer's all about. But don't be offended, please, especially for AP Calc. Any kind of calc. They might take it in high school. You need to come after my class and I'll show you. Then they can show you. Actually, it's algebra 2 that they used here. Because in algebra 2, somebody told you that x to the minus m is equal to 1 over x to the m. Somebody told you that. They didn't want to have any negative exponents. And the reason for that is if you're using numerical computer stuff, it doesn't like negative exponents. You want to be able to input a positive exponent. This is considered to be irrational for a numerical application in engineering or whatever. It's true. This is more useful for it. As long as you know that how that went down in the basement. Let's take another, oh, okay, I did that one. So now I'm going to continue with product rule and come back. I'll be back. Product rule. Product rule. Which I boldly stated, y'all heard me.
Why